Hello everyone. Welcome back for another tutorial. In today's video, we are going to be covering how to use the Desmos calculator to solve single variable equations. This is the first video in a short series that we are going to be publishing here at MentoMind and sharing with you all, covering how to use the Desmos calculator. It's a very powerful tool if you know how to use it effectively, so definitely stay tuned for more content. The Desmos calculator, if you're not familiar with it already, can be accessed in the Blue Book app. It's up in the upper right-hand corner. If you just click calculator, Desmos opens right up. It's a graphing calculator with a ton of functionality built into it. I'll just enter an equation to give you an example. So graphing functions, for example, is a great use of Desmos. Um, and it's probably the main use that you'll have for Desmos on the SAT. But I can see here, we can see that Desmos populates the coordinate plane with a function marking key points like the x-intercept, the y-intercept, a lot of functionality built into this Desmos tool. And again, plenty more content to come. Today, we'll be using the desktop version of the Desmos calculator, which is the same functionally to the Blue Book version. You can see I can open the calculator directly from the Desmos main screen. Very easy to access. If you're just working through practice problems, probably best to use the desktop version. So to solve this first problem here, it's a single variable equation. We can recognize that because we have an equal sign. Okay, so we have an equation, not an expression. And there is just one variable. There's only an x here. There's no y, there's no z. There's also no unknown constants. So we just have a single variable equation, which we might solve algebraically, but this problem can be solved pretty quickly in Desmos. Okay, so I'm just going to type this into the Desmos expression box, and Desmos will start to populate uh, the coordinate plane. So we have the square root of x minus 2 squared, and that is equal to the square root of 3x plus 34. Now we'll notice that we have these two vertical lines, and these actually are the solutions to this equation. So our work is done. These lines occur at x equals -3 and positive 10. There's nothing else to do here. Those are both the solutions to this equation. Now you could work through the algebra, of course. That would involve squaring both sides and expanding x minus 2 squared. You'd end up with a quadratic. It would get somewhat challenging, but hopefully you can see how efficiently this problem can be solved in Desmos. You also may have noticed that I used SQRT to create this radical to solve this problem. But that same symbol can also just be accessed from the keyboard. So I'd encourage you to look through the keyboard also and just familiarize with yourself with all the functionality that this app has. There is a lot built in here. So let's take a look at a few more problems. And again, these are all single variable equations solvable with a vertical line. So we can use ABS or the absolute value symbol down here, whichever you'd prefer, to generate those absolute value signs. And I'm just going to copy this equation over. X minus 5, the absolute value of x minus 5 is equal to 10. We should expect two vertical lines, and we have two. We have one at x minus 5 and another at x equals positive 15. And so those are the two solutions to this equation, okay? X is equal to -5 and positive 15 also. And that's it. Our work is done, okay? So that's all there is to it. Just punch in the equation, and the vertical lines indicate the two solutions. Now, with this problem, arguably, this can be quickly solved with Algebra 2. We just break it out into a positive or a negative solution. So we have positive 10, We also have x minus 5 is equal to negative 10. And we can get the solutions pretty quick this way also. Ultimately, whether you want to use Desmos or do the algebra is up to you. And I think there's some skill to be developed in figuring out which strategy is more efficient. So something to work on when you practice. Is it more efficient to use Desmos here or work through this problem by hand? With this next example, I think this is a good case for Desmos. And the reason is it's a quadratic with a leading coefficient of -4 that can't be canceled. We end up with fractions if we try to cancel that -4. So definitely a good, case for using the Desmos app. So I'm just going to plug this function into Desmos, and we don't even have to bring that -36 over. We can just type in the equation exactly as it appears. The solutions are -4 and 2.25. Okay, so the problem asks us for the positive solution to the equation. 2.25 is the answer, and our work is done here. Let's look at one more problem type. Again, we could think about the algebraic approach. There's not too much involved there. There's some expansion, but again, what we end up with is a quadratic equation with a leading coefficient that's not 1. We have an x squared term on the left and a 4x squared term on the right. So this is going to be somewhat challenging to figure out with algebra. So again, without any expansion whatsoever, we can just type in the equation directly. So let's see, minus 56, and this is equal to 4x times x minus 7. Okay, and there we have it. There's our solution. Okay, we have two vertical lines which indicate that the solutions are x equals 2 2/3 and also x equals 7. Okay, so x equals 2.666 or 7. So the problem is asking us for the sum of the solutions. That means that the sum of the solutions is 9.66 repeating, or we could think about it as a mixed number too, 9 2/3. And that's all there is to it. Okay, so hopefully this has been a helpful introduction to some of the functionality of this Desmos tool. But again, single variable equations, look for those on the test. A great use case for Desmos, pretty straightforward, and will save you some time. So we'll be back with more content covering more examples of how to use Desmos on the SAT. I'd also encourage you to just look at that desktop app, familiarize yourself with the keyboard and some of what's built in here. So thank you for tuning in, and look forward to picking up next time.